Good morning, Year 10. Welcome to another term. Still in lockdown, unfortunately, not together, but as I keep saying, I hope that isn't going to continue for too much longer. Anyway, if you've read my message that I put on the stream, you'll know what we're doing this term. It's slightly different. I'm not going to be setting you regular lessons with a particular topic in mind. We're going to start to work towards past paperwork. Just dip our toes into the process of working from a past paper in readiness for the exam next summer. I would have done this if we were back at school. We're not back at school, so I thought, well, you'll probably need a change from just working through lessons, so we'll do this instead. Let me remind you of the document that I posted to you at the start of last term, the GCSE higher topic list. This I will refer to from time to time when going through a paper, so you can see which are the topics that are being met. And in fact, the first thing I would encourage you to do when you're doing this paper is to get this piece of paper, to look at a question and see if you can identify which of the topics is being tested. You won't be able to do it for all of them, but quite a few of them you should be able to match up which of the topics on here goes with the question. And then, of course, that gives you the option of looking at a Heggerty for help if you wish, or of course you can always just contact me for help and I'll help you as well. So in each of the introductory lessons at the start of the week, I'm going to go through the paper and I'm going to do the paper obviously, but I'm just going to point out a few things to you as I sort of spin through the paper, what the questions are actually about. So this is non-calculator. It's the very first new non-calculator paper, the new scheme of work that came out at the end of 2016. So let's have a look at the questions. So the first question there is about probability, and just a probability of two events basically, where two things happen, and you want the probability of what happens overall. And the general rule is when they've got two separate events that are happening, you multiply together their individual probabilities to find the probability that they both happen. You should be fine with that. Question 2 is just drawing a graph. So I said in my video that I would, my message to you, that I'd point out which of the questions are ones that you might struggle to do in your book if you can't print this out. This would be the first of them. So question 1 you can definitely just do on file paper in your book, if you haven't got a book, on file paper. Question 2 you can do part A. Part B, if you haven't got any graph paper, you might struggle to do that one, though if you've got some sort of square paper, you might be able to copy that out and do it. But that would probably be the first one that you might have to leave. Okay, moving on to question 3. Stereo angles of a polygon. No reason why you can't do this one on a piece of paper. You've just got to make a copy of that diagram, its constructions, using compasses and ruler only. Obviously you need a compass. You haven't got a compass, you won't be able to do that one. Question 4, oh god, that's really easy. Both of those should be no problem for you at all. Standard form, again, if you're struggling with standard form, find a Heggerty video on it. Standard form is a topic that was on numeracy, so it won't actually be on this list here. There's hardly any number topics on this list here because this is just maths only. But if you look at our numeracy topic list, you'll see the standard form questions there. General rule of thumb is to just spat on my iPad. Yuck. Sorry about that. General rule of thumb is to change them both into standard form and then adjust the power and then do the sum on the left. So there'll be 7.5 divided by 5 in this case. And then adjust the answer if it's not between 1 and 10. For the add ones, it's sometimes easy just to change them into normal numbers, work out the answer, and then change it back into standard form. I don't know why I'm doing this for you. Question 6. Now, if it was later in the year, I wouldn't tell you what this topic actually is. You might be able to work it out for yourself. But since this is the first one, I'll tell you now, this is a simultaneous equation question. In disguise, you have to make the equations first and then solve them simultaneously. Should be very straightforward for you. Clearly this is a tree diagram question, and again, as this is the first of the year, I'm going to draw your attention to this bold "and" word here, because it is critical that you understand what they are telling you what this 0.42 is, which of the values in the table the 0.42 actually is. Well, I'll give you a little hint, it ain't the value that goes there. I'll say no more than that. It is not the value that goes there. Some other value goes there, and that goes somewhere else on the diagram. We've done tree diagrams. Hopefully you know what I mean. Inequality question. Again, this is one where you need to form the inequality before you can solve it. Remember, inequalities are just like equations, just they have less than or greater than signs. The rules of solving equations still apply. What you do to one side, you must do to the other. The only new rules are that if you switch the sides over, you have to switch the sign of the inequality, and if you times or divide by a negative, you have to switch the signs of the inequality. Other than that, it's just like solving an equation. Powers, we've done this. Fractional powers, you should know what a fractional power is. If not, you can message me or look it up on Hegarty. This one here is about solid shapes, and it says the radius of a hemisphere and the radius of a circle are equal, call it R. The hemisphere and the cylinder have equal volumes. That's the key phrase there. The hemisphere and the cylinder have equal volumes. So you need to write down an equation for the volume of the hemisphere, set it equal to an equation for the volume of the cylinder, and then you should be able to cancel out things like pi and end up with a relationship between the heights of the cylinder and the radius of the cylinder. Okay, you'll see what I mean when you do it. Inverse proportion. We've done some work on this quite recently. This is on here, so you can look up in those videos if you need to how to do that. Y equals k over if it's inversely, or y equals k times if it's not. But I know we've done that. Hopefully you remember. Now, writing as a single fraction. To write these as a single fraction, you put them over a common denominator, and that common denominator is what you get when you times the two bottom things together. Okay, but if you change the denominator of each fraction, you must change the top as well. So I'm going to end up timesing that one by 2x plus 7. So I must times the top by 2x plus 7. I'm going to end up timesing that one by 3x plus 2. So I'm going to times the top by 3x plus 2. Again, I'll give you some more help than that if you ask for it individually. Circle theorem question. I refer you to the videos on circle theorems. You might want to watch those first before taking on that question. This is a topic that we'll do again next year, so if you're struggling with that one, don't worry too much. Haven't seen much that you can't do on paper yet, apart from the one I showed you earlier with the graph paper. Everything you could do on file paper if you needed to. Now, that looks familiar. My goodness, that might actually be one of the questions that was on the very last assignment that I set you. I think it is. To do with quadratic equations. So you can find that answer if you're really stuck by looking back at my solutions to the very last bit of work that we did before half term. I've got a feeling it factorizes, so you don't need to use the quadratic formula for part B. If you're following what we did last term, you'll know what I'm talking about. Oh, question 15 from last term as well. Transformation of functions. Another topic that we did. You did it yourselves doing the videos on Hegarty. I think I started you off and then we moved to the videos. So you have to understand what f of x minus 3 does. Watch the videos if you don't. I'll go over all this on Friday. Y equals cos x. Sketching again, this will be on here somewhere. Be under shape. Here we are. Sketch the graphs of y equals sin x and y equals cos x and simple transformation. So again, you can look at those videos. Question 16. Congruent triangles. Now for this, you really need to use the correct language for congruent triangles. Again, there is a here it is. These are the correct phrases here. So these 4 things here: SSS, SAS, ASA, and RHS. If you don't know what those mean, you need to watch these videos, or some of them, to get an idea of what that's about. And again, I'll go through it at the end of the week. So question 17 is surds. So multiplying out a surd. Again, we've done this, simplifying surds. Very, very simple. The rule is, if you've got 2 things in a square root and you multiply the square roots together, you multiply the things in the square root together. So for example, the bottom there, I'll give you a clue, is the same as the square root of 64, which is 8. So that's just 8 on the bottom. Okay. Sometimes you can't get down to an actual number. You have to leave part of the answer inside the square root. That's called simplifying a surd, and it's a topic that we've done. So hopefully you can remember how to do that. Finally, the last question is another probability question. Best bet for the, I mean, some people would do this by drawing a tree diagram of their own, but it's simply what I said before. Just remember that if you do something more than once, you multiply the individual probabilities together. Okay, so in this particular one, we've got Sophia. She's trying to get a ball in a bucket, and every time she has a go, she has a probability of 0.8 of getting it in. Okay, and you've got to find, well, basically the difference between the probability of her getting it on the first throw and the probability of her getting it on the second throw, and work out and show that it's 5 times more likely that she'll have got it on the first than on the second. It's very, very easy. So anyway, that is your task for the week. Like I say, the only one that I really feel you can't do on file paper is the graph, and even that one's doable on file paper. I mean, ideally you'll print this out or do it electronically, but if you don't have those facilities, that is not an excuse not to do it. You can just do it on file paper, take photos of the file paper and turn it into this lesson in the usual way. Okay, so don't forget, this is your work for the week. Okay, if you finish this, well, this is priority, get this done first, turn it in when you've done it so I know you've done it, and I will then mark it and get it back to you with some feedback. Okay, as soon as you hand it in, I will look for those and try and get those back as quickly as I can. If you run out of things to do, okay, if you do that before the end of the week and you need to spend some more time on your maths, you can start working through these Hegarty tasks here. I have not set these as tasks themselves, so it's up to you to just type in the number, find the task, and get on with it, basically. I will keep checking to see if anybody has done any Hegarty through the week. None of this is compulsory. It's just if you're eager and you want to do some more work, that's what I want you to do next. Okay, so hope that's all clear, and you all have a good week. Keep contacting me via the lesson. Send me messages, and I will reply to you like I did last term as quickly as I possibly can. If you get stuck, I will give you help on any of the questions on this paper. And then on Friday at 9 o'clock, there will be a Google Meet session so we can get to see each other, and I can talk a little bit more about how it's gone through the week on this paper, which questions have been causing the rest of the class problems, and you can also then ask me if there's anything that you didn't really understand about one of the answers. Okay, that's it for me for now. Have a good day, everybody.